This is a short video about an NSF grant, Math Stat Projects Across the Curriculum, which we call M²AC. It's intended to empower non-STEM students to appreciate the use of quantitative modeling in their non-STEM discipline. For example, a theology major, a philosophy major, political science major. The principal investigator on this grant is Reza Abbasian, Texas Lutheran University, Department of Mathematics and Computer Science and Information Systems. And his co-principal investigator is John T. Sieben, also of Texas Lutheran University, also of the Department of Math, Computer Science, and Information Systems. The motivation behind the grant is the observation that college students do take required math and statistics courses, and here I'm thinking primarily of the non-STEM students. Many of their disciplines require that they take a math course or maybe multiple math courses and statistics courses, but there doesn't seem to be a lot of transfer from the math classroom into the classroom of their home discipline. So we needed to find a way to raise awareness of quantitative applications and to increase the non-STEM students' comfort in seeking out math applications and applying the technology that's so ubiquitous today that makes doing sophisticated math more a matter of understanding when and how the math is needed and less an understanding of the intricacies of symbolic manipulation. And we need to make these modules available to faculty members, not to create a new course, but as an add-on, one-day, two-day add-on to their existing courses, just taking advantage of something that they can easily incorporate into their course to make their course more quantitative. And to do this, we're building a reservoir, an archive of modules that can be downloaded by any interested faculty and can be applied to an existing course with absolutely minimal effort on their part. The goals of the project are to increase a student's positive attitudes and the awareness of and relevance of competency in mathematics and statistics by using mathematics and statistics in their home discipline, where hopefully they feel more at home. It's not a foreign environment, it's their home environment, and in that environment we want them to discover that quantitative tools can be extremely useful and can add to what they're learning in that home discipline. We want to increase among the faculty outside of mathematics the same sort of ease of approaching quantitative studies. We want to have some tools for them so that they can add a quantitative application to an existing course without the feeling that they're overburdening their students or that it's a burden to themselves to have to investigate a quantitative application at the same time that they're teaching their psychology course or physiology course maybe, or theology course. Turnkey is a term we use a lot here. To disseminate these ideas, we want to do things like creating this short video and appear at national and regional meetings where we can talk about these very ideas. The disciplines that we've impacted so far are kinesiology, art, economics, psychology, theology, philosophy, political science, and biology. There have been 15 faculty members involved over the last 2 summers, and these faculty members are faculty members in the target discipline, psychology, theology, and some faculty members that are mentoring the home discipline faculty. So the idea is that quantitative ideas imposed upon a, let me say, philosophy course, if the ideas come from the math faculty, they're not apt to be very well received by the theology faculty, philosophy faculty, or their students. The place where these ideas originate needs to be with faculties in the home discipline. So some of the 15 are faculty from the home discipline. Some of the 15 are mentors that are there to help create modules that are the brainchild of the faculty member in the home discipline. Most of this work is done over the summer, with the results being taught in the fall and the spring semesters as add-ons to existing courses. We have created a website. URL is listed on this slide. And the website is where the modules that are created will be stored. This is almost a placeholder because in the final analysis, we're going to have a website that is more user-friendly and has more visual impact. But here's where abstracts for the modules will be stored by discipline. Besides the abstract, there will be a student file where all the directions that a student needs to complete the module will be contained. That can be read by students or printed out and given to the students as a handout. And then finally, there is a faculty page or a lecturer's page where the faculty member can learn what needs to be done as the teaching faculty person, and also can easily have in one place background information that will enrich the students as these background details are shared by the faculty member. Some examples of modules that have been created to date. We did a small module on the V1 bombing of London during World War II. The question was, are these bombs being targeted or are they randomly falling on the city? And the defensive posture would be different depending upon the answer to that question. This is a module that would be suitable for a history course or a political science class. Another example, stylometry and its applications to identifying the true authors of contested print works. An example that I think everyone knows about is the debate over the years of who wrote Shakespeare's plays. Was it Shakespeare, or was it Bacon, or was it some other person? And stylometry uses computers to do word count and frequency counts and to try to settle the issue of, was this work likely produced by this author? Another application, predicting the number of new COVID cases in a country. In this example, multiple regression was used, with predictors being the density of the community, the population of the community, the age of the community, the wealth of the community, and a few other predictors. And how well can we predict, based upon these variables, the number of new COVID cases in a region? This module would be suitable for a course in nursing, biology, or sociology. A module that we've just completed work on would be suitable for use in theology is look into the question of what does God look like to the Gen Z population. The image that one has of the deity changes over time. And apparently, Gen Z does not see God or their religious institutions the same way that their parents and grandparents did. This module is an attempt to get a quantitative description of the differences between what God looks like to Gen Z and the effects that that has upon the decisions they make in their life. Utilizing Laplace's mark and recapture method. This was a method that was attributed to Laplace in the 1770 era, And Laplace used it to estimate the population of France. But in an application by one of our students, it's been used to estimate the number of infected cases when COVID-19 was first reported from Wuhan, China. Another example was to develop a stoppage rule in college football, and that would mean that if a college football game is, say, at halftime, decidedly lopsided, what is the probability that the winner will be the team ahead at halftime? If we could know that with, say, 95% accuracy, would it be a good decision to stop the game at halftime, award the win to the team ahead, and save the possibility of injuries that might take place in the second half? So that's an example of some of the modules that have been created. Since the primary goal was to change attitudes of students, we have to analyze the students' attitudes before they're exposed to a module and after they're exposed to a module. So to do this, a survey was created and was given as a pre-test and a post-test. It's not a content survey in that it doesn't try to measure how much math or statistics a student knows, but to measure the attitude towards statistics. Sample questions would be like, I truly enjoy math and/or statistics, or I can use Excel or other math stat software to run basic statistics, or I understand the importance of math statistics procedures to test the validity of a claim, and so forth. In total, there were 38 such items on the survey. This was administered pre and post and was used to measure the change in attitude toward math and stat modeling. We're analyzing with principal factor analyses, and we have 4 factors that we're looking at: the disposition toward mathematics and statistics, the comfort level in using math and statistics, visualizing applications of math and statistics in the home discipline, and how one feels about the value of quantified data. Over 3 years of the project, we expect to gather data from 500 to 600 participants, and so we'll have a fairly sizable and representative sample of students on which to base our analysis. For future work, we hope to develop more modules in the summer of 2022. We'll gather more data because we will have 3 additional semesters in which to try these modules in class, and we will continue with the analysis of the data that we gather. We also plan to disseminate the results of our experiment here by attendance at national math and statistics conferences and by participation in non-STEM discipline-specific conferences. We would like to acknowledge the National Science Foundation for the grant that has made this possible. We acknowledge help from Texas Lutheran University, our home institution, for help with the grant writing, and we acknowledge the help of our colleagues and students who have worked with us during these summers.